Welcome back to the deep dive. We are looking at the Azure updates from the week of February 9th to February 18th, 2026. And honestly, looking at the stack of documentation for this week, I feel like we need to distinguish between what is just a hype cycle and what is actual production engineering.
That is a very fair distinction to make, especially with this week's material.
Because usually we have the AI announcements over here, which are, theoretical, expensive, often vague, and then we have the infrastructure updates over there, the Kubernetes networking, the actual machinery that runs the business. But this week, the lines are blurring significantly.
They really are. We are seeing agentic workflows actually landing in the CLI tools we use to manage clusters. And on the flip side, we have some massive maturity updates for AKS that effectively remove the last valid technical excuses for not automating your infrastructure.
Right. So our mission today, as we dig into these sources, is to figure out if these agents are actually ready to be let loose in a production environment, and if node auto-provisioning has finally matured enough for the enterprise. We also have .NET 10, some storage performance updates, and networking changes to cover.
It is a dense week. Let us get into it.
I want to start with this agentic shift. We have been hearing about agents for 2 years now, but looking at the Azure Databricks updates, specifically Update 1 and 13, it feels like the definition is finally hardening into something architectural.
Yeah, it is.
We have Claude Sonnet 4.6 landing and model serving, and this supervisor agent going generally available.
It is definitely hardening. Let us start with the model itself, Claude Sonnet 4.6. You might look at the release notes and think, great, another model on the list. But the documentation specifically flags it for agentic workflows and complex coding tasks.
Which implies it is not just about generating text or summarizing emails, it is about reasoning.
Reasoning and state maintenance. That is the critical differentiator here.
Yeah.
If you are just building a standard chatbot, almost any frontier model works fine. But if you are building an agent that needs to go query a database, write a Python script to process that data, and then format a report based on the output, you need a model that does not lose the context or the plot halfway through the execution.
Right.
That is exactly what Sonnet 4.6 is targeting. It's built for multi-step execution.
And that pairs directly with the supervisor agent in the Databricks platform. They call it a dynamic supervisor pattern. Yeah. To me, that sounds like we are introducing an orchestration layer specifically for AI.
We are. And it is highly necessary at this stage.
Yeah.
In a complex system, you cannot rely on one giant model or one massive prompt to do everything reliably. You have specialized agents. You have a coder agent, a researcher agent, a reviewer. The supervisor's job is not to do the actual work. Its job is to route the traffic. It understands the state of the workflow and decides who needs to act next.
So it acts as the orchestrator.
Precisely. It turns a chaotic group of independent bots into a reliable, directed pipeline. It understands dependencies. It knows that the coder cannot run until the researcher has finished fetching the data. That is what the dynamic supervisor pattern provides.
Okay, so that is the AI side of the house, but this is where I actually paused when reading the notes. We have updates for Azure Kubernetes Service, or AKS, that utilize the Model Context Protocol and introduce CLI tools for agents. This is Update 2 and 3. Are we literally giving AI agents command line access to our clusters now?
We are. And I know your immediate reaction as an architect is probably that it is a security nightmare.
It is absolutely a security nightmare. I mean, I spent 10 years trying to take SSH access away from humans, and now we are handing the keys to a probabilistic model that seems incredibly reckless.
Well, let's look at the implementation, because the engineering team actually addresses that recklessness. These updates are not just giving the agent a raw bash shell. They introduce call as and call kubectl. These are tools specifically designed for the MCP.
The Model Context Protocol. Walk us through the MCP for a second.
Sure. So the Model Context Protocol is a standard way for AI models to interface with external tools securely. Instead of the AI trying to hallucinate a kubectl command based on training data from 3 years ago, the MCP server provides a strict documented interface.
Right.
It tells the AI, here are the exact arguments you can use. Here is the schema you must follow. It heavily constrains the model to valid, safe operations.
Okay, that is vastly better than a raw shell.
Yeah.
But permissions are still the core issue here. If I ask the agent to delete a namespace and I am a cluster admin, does it just do it?
That brings us to the cluster mode update. This is the crucial fix for that exact permission problem. Previously, diagnostic agents often ran with the user's context. If you were a cluster admin, the bot was essentially a cluster admin.
Which is obviously terrifying in a real production setting.
Correct. Cluster mode completely decouples that identity. You deploy the agent effectively as a standard Kubernetes resource. like a pod or a service. It gets its own service account and its own RBAC bindings. So you can give the agent read-only access to logs and events, but absolutely zero write access.
So we treat the agent exactly like any other microservice. It has a localized, least privilege identity.
That is the shoat we are seeing. It moves the agent from being a user proxy to being a defined, standardized piece of infrastructure. That is really the only way this works in an enterprise environment without violating every compliance standard on the books.
It sounds like we are moving toward a world where the agent is becoming a standard infrastructure primitive. You have your pods, your services, your ingress, and now your agents. And you have to secure and version them, just like anything else.
I think that is an incredibly accurate assessment of where the industry is heading. We are fully operationalizing the AI.
Speaking of operationalizing things, let us pivot to the core AKS updates. Because while agents are interesting, node auto-provisioning is what actually impacts the bottom line today. And for a long time, NAP had a big asterisk next to it for a lot of enterprise users.
It had a very long list of asterisks. NAP, which is essentially the Carpenter project regarding its behavior on Azure, is great in theory. It looks at your unschedulable pods and spins up the perfect VM size to fit them right then and there. No more managing static node pools.
Yeah.
But if you were in a highly regulated industry or had a complex network topology, you simply could not use it.
And reading through updates 10.6, 7, and 8 this week, Microsoft basically removed the biggest blockers on that list.
They did. We need to look at the big three here: government cloud, local DNS, and encryption.
Let us start with the government piece. NAP is now generally available in Azure Gov and private clouds.
This is massive for the public sector. These environments are notoriously rigid. You provision a set capacity and you pay for it, whether it is utilized or not. Bringing NAP there means dynamic elasticity is finally compliant for government workloads. It brings the financial efficiency of the commercial cloud directly into the restricted cloud.
But the networking one, LocalDNS, that was the one that bit me personally on a project last year. Why was that such a fundamental technical deal breaker?
So NAP nodes are created dynamically and very quickly. When they spin up, they need to integrate with your virtual network immediately to be useful. Previously, NAP did not support custom local DNS configurations during that initial bootstrap phase.
Which means if my application relies on an internal custom DNS server just to find the database.
Exactly. The app tries to resolve your internal database URL, fails because the node has not picked up the custom DNS yet and the pod crashes. The node is physically there and running, but the networking plumbing is not correct yet.
Right.
Now that local DNS is fully supported, the node inherits the correct DNS settings exactly at boot time. It effectively unblocks all those hybrid cloud scenarios where you heavily rely on on-premise DNS resolvers.
And then the security layer, encryption at host.
Again, this is a strict compliance binary for most large organizations. Many banks and healthcare providers require encryption at host, meaning the data is encrypted on the actual VM hardware before it even moves to the storage service.
Yeah.
NAP simply did not support this initially. Now it does. It also supports disk encryption sets.
So if you are a platform engineer and you have been telling your management that we cannot use auto-provisioning because of strict compliance rules, those excuses are effectively gone.
They're largely gone. If you are not evaluating NAP today, you really need to revisit why. The operational overhead of managing node pools, manually guessing how many nodes you need, scaling them up and down during peak hours. It is becoming harder to justify when the automated solution now natively supports all these advanced configurations.
Staying on the theme of reducing operational overhead, let us talk about the application gateway for containers. This is update 14.
This is a significant quality of life improvement for cluster operators. Managing ingress is almost always a pain point in Kubernetes. The application gateway for containers is powerful, but traditionally you had to manage the ALB controller yourself.
Which means installing a Helm chart, updating it, worrying about version skew between the controller and the actual gateway hardware.
Exactly. It was just more YAML sprawl to manage and maintain. This update makes it a fully managed add-on. You flip a switch in the AKS configuration, and Azure completely manages the lifecycle of that controller. They handle the patching them, the versioning, the scaling of the controller itself.
It sounds minor on paper, but it is one less moving part to break during a late-night cluster upgrade.
And that matters immensely for site reliability.
We also saw a very specific networking update for Azure Front Door Premium regarding the UAE North region, update 12.
Yes, support for Azure Private Link Origins, specifically in UAE North.
Why call out a specific geographic region like that in the main update stream?
It really highlights the strict data residency trends we are seeing globally. If you are operating in the UAE, you likely have very strict rules about traffic exposure and exactly where data is allowed to travel. You want the global reach of front door for caching and edge performance, but you absolutely do not want your origin server in UAE North exposed to the public internet in any way.
So private link acts as the secure tunnel.
Correct. Traffic hits the front door edge nodes, globally rides the private Microsoft backbone, and enters your application in UAE North via a completely private IP address. The origin is completely dark to the public internet. It meets the local security requirements without sacrificing the global CDN performance.
Let us move to segment 4, developer velocity and performance. We have updates for .NET Serverless and databases, and I know the .NET crowd is always watching the version numbers fly by. .NET 10 support is already here for Azure Functions in Update 5.
It is here, but the truly interesting part is not just the number 10, it is the underlying architecture. This is supported exclusively on the isolated worker model.
We have discussed isolated worker briefly before, but remind us why this is the definitive future direction for serverless functions.
In the old in-process model, your custom code and the underlying Azure Functions runtime shared the exact same process. It was fast, but it meant you were heavily locked to whatever .NET version the host supported. If Azure was not ready for .NET 10, you could not use .NET 10.
You were tightly coupled to the platform's update cycle.
Exactly. The isolated worker model breaks that coupling entirely. Your function runs in a completely separate process from the host. You bring your own dependencies, your own custom middleware, and yes, your own .NET version. This is exactly why we are seeing .NET 10's support land so quickly, because the core platform does not need to change, only your specific worker does.
That decoupling seems to be the theme everywhere we look this week. Decoupling agents from these user identities, decoupling nodes from static pools, decoupling runtimes from hosts.
It is the natural maturation of the cloud. We are moving from platform as a service, where you take exactly what you are given, to highly composable architectures, where you bring exactly what you need and nothing more.
Speaking of knowing what you need, let us talk about knowing what you actually have. Flex Consumption plans got some new troubleshooting tools in Update 4.
This directly addresses the black box problem of serverless deployments. Flex Consumption is a great tier. It scales to 0, it handles incredibly high concurrency, but when it does not scale, developers are often flying completely blind. They ask, is it my code? Is it a platform limit? Did I configure something wrong?
Usually we just blame the platform by default.
That is the standard developer reaction. But now we have actual visibility into Flex Consumption quota limits directly in the tooling. You can see exactly how close you are to your specific instance caps or your memory limits. It turns what used to be a multi-day support ticket into a 5-second dashboard check.
Finally, let us hit storage and databases. 2 updates here: SQL projects in VS Code and instant access for disk snapshots.
The SQL update 11 is a nice efficiency win. Moving database deployments natively into VS Code via the new SQL projects publish dialog just keeps the developer in their flow state. But the disk snapshot update 9 is the real technical win for operations teams.
Instant access for premium SSD, V2, and Ultra disks. How is that functionally different from how snapshots worked before?
Historically, taking snapshots on Azure and frankly on other major clouds often involved a background copy phase. You initiate the snapshot, but if you try to restore a brand new disk from it immediately, you might hit massive performance penalties or delays while the data is fully hydrated from the back-end storage layer.
So the restore was not really instant in terms of actual usability and IOPS.
Right. It was instant logically, meaning the disk object appeared in the API, but the actual physical performance was not fully there yet. This update completely removes that lag. You take a snapshot, you create a new disk from it, and you can hammer that new disk immediately with full provision performance.
That is absolutely massive for disaster recovery testing scenarios.
Or CI/CD pipelines. Imagine dynamically spinning up a perfect block-level copy of your 5 terabyte production database just to run a specialized test suite and then destroying it. If you have to wait 20 minutes for the storage to warm up before the test can even run that pipeline, fails or times out, now it's a fully viable pattern.
So looking back at the entire stack of updates from this week, February 9th to the 18th, what is the grand synthesis here? We have AI agents getting standardized AKS, fixing its enterprise compliance gaps, and core storage getting demonstrably faster.
I think the synthesis is definitely standardization. We are moving rapidly past the experimental phase of this new AI era of cloud computing.
How so specifically?
Look at the agent updates we started with. We are not just throwing random Python scripts at an LLM API anymore. We have a defined supervisor pattern. We have cluster mode for identity decoupling. We have the model context protocol standardizing the tool interface. We are actively building the governance layer for AI right into the infrastructure.
And on the infrastructure side, with things like node auto-provisioning, we are standardizing on zero-ops compute.
Exactly. The end goal is to stop manually managing nodes and to stop micromanaging fragile AI prompts. We are building systems that fundamentally manage themselves, provided we, as the engineers, set the guardrails correctly up front.
Which brings me to a final thought for you to consider as we wrap up this week. We have spent the last 10 years learning how to secure containers. Scanning images, locking down network ports, managing secrets and key vaults. If agents are truly the new primitive, as we just saw with the CLI tools, are we ready for agent security to become a full-time job?
I do not think we have a choice in the matter. You are going to have agent sprawl just like you had virtual machine sprawl and container sprawl before that. You will need to version control their specific prompts, audit their decision logs constantly, and revoke their access dynamically when they inevitably go rogue or hallucinate.
Yeah.
The call kubectl tool is just the very first endpoint in a very large, entirely new attack surface.
A sobering thought to end on. Managing the vast army of robots we just built.
I prefer to call it guaranteed job security for all the cloud architects listening.
That is definitely one way to see it. Thanks for taking the time to go through this deep dive into the source material with us. Make sure you check your Flex consumption quotas, look into enabling cluster mode for your deployments, and we will see you in the next one.